looks like the stream is running. Hi everyone, I'm TigerHawk3. Today we're going to look at Python's OS module, which is very handy. It's actually popular to learn in Python classes. Judging by an N of 1, when I took a Python class, there was some stuff with the OS module. So, it's basically for, it's an interface to specific stuff that your OS has and can do, like file system, console stuff, and so on. But when one operating system has another way of doing pretty much the same thing as a different OS, they're different under the hood in the OS module, but the interface to you is the same. So, this is a very long module. I think it will have more than one stream day. Availability, Unix. So I'm looking at the documentation, and each function has it lists what OSs can access that function. For example, the first one is os.ctermid, which returns the file name corresponding to the controlling terminal of the process. It's only available on Unix systems. So I'm not doing that because I'm on Windows 8.1. Environ. What is this? A mapping object. Let's take a look. Wow. That's I guess that's my environment variables representing the string environment. Yeah. Okay. Delightful. Thanks. Smile and walk away slowly. There's os.environb, which returns a bytes version of this, which is a string. These functions are described in files and directories, so they're described somewhere else. Files and directories in OS. For real? Okay. Maybe we'll get there later, or I don't know why they list it multiple times. Let's go through them now, and when we get to the later segment in which they are actually described, we will simply say, and we have seen this. Let's move on. So, I'm sure you've seen me use this because I have done it a few times on stream already. To change the working directory. By default, it chooses the directory where you were when you started the interpreter. So I started it at my home directory. C users TigerHawk3. Is that it? Yeah, C users TigerHawk3. So here's where I was in PowerShell, and then I started the interpreter, and so that's going to be my working directory, and we shall see. So that's where we are, but I can change this if I want to work with files that are somewhere else more conveniently. Or if I want to import a module, it's kind of inconvenient to import something from a directory that you're not in. So if I had some Python file that I wanted to import as a module, and it was on my desktop, I would go os.chdr desktop. And then I can check again, and I'm on the desktop. That's great. fchdir. Change the current working directory to the directory represented by the file descriptor that you pass. So instead of a string, this function can support specifying a file descriptor. Pathfd can be a file descriptor. I'm not entirely sure what that is, but it's not telling me. That's okay. But there's there's this with an F in the beginning for passing a file descriptor instead of a string, although this can also take a file descriptor, so I don't know what's up with that. Get CWD. I just used that. So there we go. Get CWD shows you your current working directory. Handy. fs encode. Encode the passed file name to the file system encoding. With surrogate escape, error handler, or strict on Windows, return bytes unchanged. There's going to be a few functions that I think are less likely for most people to use, and I'm going to mention them, but mostly skip them. Like fs encode. Encodes the file name to the file system encoding. Great. fs decode. Same as previous, but backwards. Get_env. Return the value of the environment variable key, which you pass if it exists, or default if it doesn't. os.getEnv. Is it Python, I think, is a thing? 3. What this means is that when I write py, as a command at the command line, like I did at the beginning of the stream, it starts Python 3 rather than 2. You don't want that. You don't want it to start the wrong version, because then you get crazy stuff. Like make a big range object and your computer explodes. Bad. Anyway, get_env_b, which does the same thing, only returns bytes instead of a string. Oh, key, default, and the result are bytes. So get_env_b requires that this be... This should not work. It did not work. Wait. Get_env_b has no attribute. Get_env_b, yes it does. Ooh. Availability, most flavors of Unix. Okay. Didn't see that part, because get_env is Unix and Windows. And get_env_b is apparently only Unix. So, okay then. Technically, I did say it wouldn't work, but it happened to fail for an unexpected reason. Get_execpath returns the list of directories that will be searched for named executable, similar to a shell when launching a process. And when specified, should be an environment variable dictionary to look up the path in. By default, when it's none, environment is used. West.get_execpath. What the heck is this? I don't really know. Is it the same as previous? It is not. I guess this is a whole bunch of folder paths where things would be looked up. Can you see here, by the way? Python is 3. It's not quite visible. It says 3. Get_EGID to return the effective group ID, only Unix. Get_EUID. Get the effective user ID, only on Unix. Get_GID. Get the group ID on Unix. Get_group list. Unix, get groups, Unix, get login, Unix, and Windows. Return the name of the user logged in on the controlling terminal of the process. That's me! Works. Great. Get PGID, return the process group ID, Unix. Get PGRP, Unix. Get PID, return the current process ID. What process? 13408. I don't know which process that is. Maybe it's Python? I don't know. Would that be listed here? I don't know. Get PPID, return the parent's process ID. We're gonna skip that one. Get priority, Unix. Availability, PRIO process, PRIO PGRP, PRIO user, Unix. Get res UID, Unix. Get res GID, Unix. Get UID, Unix. Init groups, Unix. Put env to set an environment variable, and it takes a key and a value. I'm not going to mess with that because I don't want to change my environment variables. They are quite happy as they are. Thank you. Set EGID. I mean, I'll show you what it looks like. I could do os.putenv python, and I could do 2, and that would set it to 2 instead. And then once I, realized what I was doing and went, oh, no, I don't want that, definitely not, I would put it back to 3. Set EGID Unix, set EUID Unix, 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 Unix. These are all Unix. A lot of getters and setters. os.str error. Return the error message corresponding to the error code in the past code. I don't know what code can be. Doesn't say if it's an integer or some error code object. I have no idea. os.supports bytes environ. False. This is probably why there's no environ B and similar things on this environment currently, because it doesn't support it. So there we are. os.umask, set the current numeric umask and return the previous umask. I don't know what that is. I'm not touching that. os.uname returns information identifying the current operating system. Availability recent flavors Unix. Never mind. os.unsetEnv. Unset or delete the environment variable named key. So I'm not going to do that, but it is available on Windows. Yay. os.fdopen. Return an open file object connected to the file descriptor fd, which you pass. Oh, it's an alias of open. Okay. The only difference is that the first argument must always be an integer instead of a string with the name of it. Okay. I can see myself not using that as much as I use open, especially since open is built in. I think... yeah, there's also an os.open function. And if you do from os import star, that will mask the built-in function open. And then you will try to use open, and you will get problems, because it's using the OS version of open, which is a little different. So, that's something. Import star is something you shouldn't do. Just don't. There's os.close, which lets you close a file descriptor as returned by os.open or pipe. To close a file object returned by the built-in function open, or by popen, or by fdopen, use its close method. So if you use os.open to open a file, you use os.close, and you pass it the file descriptor. If you open a file with the built-in open function, or a few others, you close it by saying this file object dot close. It's a method of that object. Or you can just open it the right way in the first place with a context manager, which means with open something as the name or whatever, and then when you finish that with block, it will automatically close the file for you, even if there is an error somewhere. You're guaranteed to not be left with open file descriptors hanging around, so that's cool. I highly recommend using with. os.closeRange closes all file descriptors in a range from between two numbers that you pass it. Let's not do that. os.deviceEncoding. With the file descriptor, return a duplicate of file descriptor. This is all file descriptor stuff. The average Python user is unlikely to be messing with this stuff, and a lot of it is only available on Unix. Okay, a few things. fstat-vfs. You can look up the documentation on your own if you want. I don't think it's super useful to be reading everything aloud. At least it's not a PowerPoint that you're looking at, right? If you ever find yourself showing people a PowerPoint presentation and you're just narrating the content of the slides, stop. Don't do that. Put a lot less information on your slides. Like maybe you have the title and then like the main kind of subtitle of a bullet and then some kind of description. Take out all the description and probably all the bullet points. Just leave it with the title. Like if you have results for the title. And then one of your bullet points is product availability. The product was successfully unveiled in all target markets. And then the next bullet might be revenue. And then the description of that might be 70% of revenue targets were met within 3 months, or whatever. You can take out all that. Your slide could just be the word results right in the middle, and then you talk about the results like a human being. If you need to show a graph, you can put a graph in there. But it's PowerPoint is not Word. You don't write your speech in it. Availability, Unix. File descriptor stuff. I don't want that. I don't want any of this. os.open. Open the file path. File descriptor. So there's an os.open. I've never seen anyone use it. I've only seen people call it accidentally when they're meaning to use the built-in open. And they end up with this one because they imported everything into the global namespace. It's bad. Following constants are options for the flags parameter to the open function. They can be combined using the bitwise OR operator. That's efficient. Some of them are not available on all platforms. Let's look at some that are available on Windows. os.o_read only is 0. How about write only? 1. That's great. RDWR, read write, I guess. Append is 8. That's great. That's great. And now we create. Notice how these are all powers of 2? That is why we can use a bitwise OR operator. If you have, if you are making a poll for a forum post or something, and you want people to be able to, not just for a forum post, if you have a survey of some kind and you'd like to know how many widgets people customarily use on Tuesday, whatever, how many pencils do you own? I don't know. It's common to do like 0, 1, 2, 3, 4 plus, and then anyone who has 4 or more just goes with the 4 plus. What if you want a more specific measurement? You don't want to have a million different things, right? So what you do is you use binary. You have a checkbox with, and this needs multiple selection because you're creating a binary number. You have a checkbox that says 1, and then after that you have a checkbox that says 2, and then after that you have a checkbox that says 4, and then 8. So if they have, say, 5, they'll check the 1 box and the 4 box. If they have 3, they check the 1 box and the 2 box. That's how binary numbers work. You can also do that with counting on your fingers. You've got 10 bits over here. Most likely, if you have 10 fingers. Maybe some of my viewers do not have 10 fingers. A friend of mine has 9.5 fingers. Because, table saw. They are very dangerous. He's a chef. He spends a lot of time using knives. He's an avid outdoorsman. He spends a lot of time using guns. Never a problem, really, with those. But a table saw. Yeah, those are very hazardous tools. Anyway, instead of going, 1, 2, 3, 4, 5, right? You go 1, and then 2, and then 3, right? So, you have 10 bits. You can do 2 to the 10, which is you can count to 1024 on your fingers, assuming you have good motor skills, because you'll end up like with something like this, or I don't know, depending on the number you have. Well, 1023, I guess, with all 10. Or actually, no, 1024. You have 1025 numbers you can represent. 1024 with all 10, or, 0. Is that right? Yeah. That's correct. Anyway, where were we? Talking about table saws. These constants are only available on Windows. OS.O binary. No inherit. You get the idea. They are constant flags of integers that you can combine together with bitwise operations, because they're all powers of 2. Fantastic. Open PTY. Open a new pseudo-terminal pair. Only Unix. Let's move on. os.pipe. Create a pipe. Return a pair of file descriptors usable for reading and writing, respectively. The new file descriptor is non-inheritable. I'm not sure how to use this because it doesn't say anything about it. os.pipe2. Create a pipe with flags set atomically. Flags can be constructed by ORing together one or more of these values. It's only on Unix anyway, I don't care. Another one, Unix. os.read. Read a given amount of bytes from the given file descriptor. Return a byte string containing the bytes read. Great. At the end is reached, an empty bytes object is returned. Okay. In 3.5, which I am not running yet, if the system call is interrupted and the signal handler does not raise an exception, the function now retries the system call instead of raising an interrupted error exception. Okay. os.send file. Copy some number of bytes from one file descriptor to another. Only on Unix. os.write. Write a byte string to a file descriptor. Write v, only Unix. Querying the size of a terminal. Can I do this? Is this actually available on Windows? Oh my god. Get terminal size. 120 columns by 50 lines. That is the size of the terminal window that I'm using. The standard is 80 columns and 24 lines. That is and that's not some standard that was agreed upon for various reasons that are, documented in PDF somewhere. It was they made a terminal, printer thing. That's what it could handle. That was the hardware that they made at the time, several decades ago. And some people still use that size, even when it's a tiny little thing in their gigantic monitor. I think there's no need for that. That's why I have 120 columns and 50 lines. It is kind of a personal choice of how large you want the terminal to be, but and I'm not saying that it's reasonable to have, unlimited size as big as your monitor, but it's not limited by the monitor anymore, is the point. So I pick a size that I like, and it's about 120 columns. 150 starts to look a little, read from one end to the other. So I stick with this. Oh, there's a class, os.terminalSize, which is a subclass of a tuple, and it holds columns and lines of the terminal window size. Great. So notice how this returned an object, and that's this terminal size type. So I could do the last thing that was given to the interpreter is this, and it's the type. It's an os.terminalSize object, whatever. Inheritance of file descriptors, new in 3.4, which I am running. Get inheritable, set inheritable, I really don't care. It doesn't matter. Files and directories, half an hour. Maybe we'll actually go through the whole thing, because this is a lot of stuff that I don't care about. On some Unix platforms, many of these functions support one or more of these features. Like os.access, no. Is this all Unix? Is my question. I think this is only a few features that are Unix specific, and let's see if I have it. It exists. Okay. Built-in function. That's weird. Using access to check if a user is authorized to to, for example, open a file before actually doing so, using open creates a security hole because the user might exploit the short time interval between checking and opening the file to manipulate it. I see. If access okay, then open it. I see. That's interesting. They say not to use this access thing. Using access to check if a user is authorized to access a file before you open a file with open. The user might exploit the short time interval between checking and opening to manipulate it. I don't know how, but okay. It says instead of using if os.access my file is os.r okay. So if access is, granted for this user, with open my file as fp, return fp.read. So if access is acceptable, do something with the file, right? It says you should actually use a try except. Try to just open the file, and if there's a permission error, you catch that and handle it. That's interesting. Change directory, which we covered previously because it was mentioned before and saying just like see later, and here we are. ch flags, to set the flags of a path to the numeric flags. No. os.chmod, to change mode. Change the mode of a file given by a path. Although Windows supports change mode, you can only set the file's read-only flag with it. All other bits are ignored. It doesn't really do anything. That's great. Availability Unix. Get CWD. We did that. It's very handy. Unix. Wow. os.link. Create a hard link pointing to the source named destination. I don't actually know what a hard link is. Here we are. Something useful. Goodness gracious. os.change directory dot, right? And let's see what we've got. All right. Okay, this looks good. Check this out. We're going to print os.list dir, and we're not going to pass any argument. That's not useful. Let's do that. Because the default value is a dot, just a single period, which means the current directory. So this is going to give us a listing of everything in the current directory. And I passed it to print, unpacking it and saying the separator between all these arguments should be a new line. That's all the files and folders in my home directory. Android Studio. I don't enjoy Android stuff, but it's there. I use Git, blah blah blah, VirtualBox. I tried more Android stuff. That's what that's with. And mostly things that come with come with a system on a regular install. Genymotion is another emulator for Android, which also doesn't work for me. I tried to use that, and it said it couldn't start the emulator on its own. Go into VirtualBox and make one yourself. Then I'm like, and it couldn't do that either. And then it said go into your into the BIOS and turn on emulation, virtualization, etc. And I'm like, it doesn't work. Fine. Anyway, this os.lister, just fun fact, in Python 3.5, there's a function called scandir, and lister is now just lister in 3.5 is just an alias of scandir, and the difference is, on Windows at least, scandir is somewhere between 7 and 20 times faster than lister, and has other similar but not identical speedups on other systems. So it's just does the same thing but much, much better. I suppose it would make a difference if you had a very large directory. A directory with lots of stuff in it. lstat. Perform the equivalent of an lstat system call on the given path. I don't know what that does. I don't know what lstat is as a system call. Excuse me. So I'm not going to do it. os.makedir. New folder, and this would create a new directory wherever we are. So that's cool. If it already exists, it raises an error. Some systems ignore the mode. The mode is 00777. That's not the letter O. And 00777 is octal, which comes out to decimal 511. That's the permissions mode for this file. This directory that you're making, sorry. Blah, blah, blah. I don't care. MakeDirs. So there's os.makedir to make one, and there's make spelled out, DIRS. And that's recursive directory creation. Makes all intermediate level directories needed to contain the leaf directory. So I could do I guess files / stuff, and then it would make the files directory, and then inside that the stuff directory. I don't know why it needs to be recursive, but okay. Make FIFO. Create a FIFO, a named pipe. Oh, only Unix. Next song. That's a Tenacious D track. That's he makes a song consisting of one note, and it goes. That's his song, and he says, "I made that." Next song. Let's move on. Next song, because his buddy's like, that's not really. Is that? No. So, entertaining musical group. Make node. I don't care. os.major. For device. Extract the device major number from a raw device number. No. Minor, make dev. No. Unix. There's a bunch of stuff. Here we are. Here's a thing that you might use, west.remove, to delete a file. If it's a directory, it raises an error. There's a separate function, which is rmdir, and that removes a directory. On Windows, attempting to remove a file that is in use causes an exception to be raised. Windows really doesn't like you trying to change stuff that's open. For things that are hard to see what they're actually in use by, if a file is in use by like the system or something, and like a temporary or hidden thing, and you're trying to delete it because it doesn't seem to do anything, it might be like, nope, this is in use, you can never delete it ever. So yeah, that's a thing that Windows likes to do. On Unix, the directory entry is removed, but the storage allocated to the file is not made available until the original file is no longer in use. So that's pretty cool. On Windows, if you try to delete a file that's open, it just crashes. On Unix, it kind of it says, oh, it's in use. Well, I'm going to take it out of the directory, but I'm going to leave it doing whatever it's doing, and as soon as it is closed, not in use anymore, it's gone. That's excellent. I like that. Remove DIRs. Remove directories recursively. If the leaf directory is successfully removed, it tries to successfully remove every parent directory mentioned in the path until an error is raised, which is ignored because it generally means that parent directory is not empty. Okay. If we do remove dirs, foo, bar, baz, these are commonly used nonsense words to just say, like, instead of XYZ, because they're more word-like. This will first remove the directory foo/bar/baz, the baz directory up over in this location, and then remove bar, and then remove foo if they're empty. If the leaf directory can't be removed, it raises an error. os.rename lets you rename stuff, a file. os.rename myfile.txt to newName.txt. That's pretty much it. Source directory file descriptor. This function can support specifying source directory file descriptor and or destination directory file descriptor to supply paths relative to directory descriptors. Great, I don't understand that. os.renames, a recursive directory or file renaming function. Okay. os.replace. How is this different? Rename the file or directory this to that, if it's a directory. If it exists and is a file. Oh, rename says on Unix, if it exists and is a file, it will be replaced silently, it'll just do it. But replace doesn't specify Unix, so maybe it'll work like that on Windows as well. That's pretty much all it says. No, it's rename says the operation may fail on some Unix flavors if the source and destination are in different file systems, while replace just says the operation may fail if source and destination are in different file systems. This is a POSIX requirement. So replace seems to just take out a lot of the OS specific stuff. Rename says on Windows, if the destination already exists, it'll raise an OS error even if it's a file. That's not mentioned at all in replace. So replace seems like it's new in version 3.3. So maybe it's just maybe os.replace is kind of intended to replace the rename function. I don't know. It doesn't really say. rmdir, remove or delete the directory. os.scandir, new in version 3.5. So first it says what it does, short paragraph. Using scandir instead of listdir can significantly increase the performance of code that also needs file type or file attribute information because dir entry objects expose this information if the operating system provides it when scanning a directory. All dir entry methods excuse me, let me perform a system call. On Unix, the path can be string or bytes. On Windows, it has to be a string. The type of the name and path attributes of each dir entry will be of the same type as the path. So it'll kind of go with what you started with. This is interesting. So is instead of like for file and listdir, because remember listdir just gave us this list of strings, is what those are. The example for scandir says for entry in os.scandir with a path, if not entry.name starts with, so each it's not just a string, it has a name in it. And you can check whether it's a file. Interesting. So it actually behaves differently. Cool. os.dir entry, a class. Object yielded by scandir. Long day. Okay, not really. I got up at like 1 p.m. But I'm tired. Sorry. So this is a class used with scandir. Probably don't even have this class. Let's find out. Nope. Doesn't exist. 3.5 only. 3.5 has some cool stuff. I'm kind of waiting till 3.6. I don't like the idea of as soon as there's some new version, upgrade immediately. Because I don't really want things to break. They probably won't. I'm sure they won't. But I'm a little paranoid about that stuff. Don't want to Jenga my computer, you know. If you don't know what Jenga is, it's make a little tower of blocks, and the game is to remove blocks from the structure and stack them on top to kind of build up the structure, and sooner or later removing bits of it is going to cause it to fall down, and when it does, that's Jenga. I don't know why they call it that, but Jenga is the name. I use that term whenever I want to describe whose fault something is and wanting to avoid breaking something. Taking out little important bits of something little by little, and eventually it explodes. So we're going to skip this class, os.stat. Get the status of a file or a file descriptor. How about that foobar.txt? Does it work like this? It does. Goodness. Let's print this, unpack it, and do a custom separator. see. It's an os.statResult thing. Alrighty. Maybe not. So there's an stmode, stino, stdev. I don't know what any of the stuff is, and I don't particularly care. Let's move on from some of those things. 50 minutes. I'm gonna see if there's anything. I'm gonna skip stuff more quickly. os.symlink to create a symbolic link. I don't know what symlink is and hardlink. On Windows, a symlink represents either a file or a directory and does not morph to the target dynamically. Let's just skip that. os.sync, force write everything to disk, Unix. os.truncate, truncate the file corresponding to the path. So os.truncate lets you pass in a file and give it a length, and it will cut off all the bytes past that length. Okay. And it's only supported on Windows in 3.5. os.unlink, remove the file path, semantically identical to remove. I don't care. Set the access and modified times. No. os.walk. This one is cool. Let's look at os.walk. Generate the file names in a directory tree by walking the tree either top down or bottom up. For each directory in the tree rooted at directory top, including top itself, it yields a 3-tuple. String. Alright. So walk basically allows you to kind of walk through a directory. And I believe it's recursive. Allows you to do that. For path, name, and file names in os.walk, the current directory. Print. What does this do? Goodness gracious. Stop. Too much. Too much, computer. So this was walking through everything. So this gave me blah 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 blah. Here we are. So here's the end of this list. So this is the directory path, and here's the directory names, and here's the file names. And then I suppose it continues on. And there's more. Yeah, this is when top down is true, the caller can modify the names list in place and will only recurse into. So this is recursive. That's why it started giving me so much stuff, like I said. Let's go into something more specific. Golly. Okay. All right. Let's change to somewhere. Where am I gonna go? I'm looking for something with an interesting but not too complex directory structure that I can show you. How about Ford? Java? Okay. This looks like files and folders. Oh, there's a lot of stuff there. Could be good though. I'll probably go with that. I have a folder called Sound, and there are two sound files. One is 83 meg, and they're both 83 meg. Exactly. I'll have to look into those at some point. What the heck are they? DOS progs? That's too many files. I'll tell you what. I have many files, my goodness. Okay. How about Java? The Java folder. F Java. This is from my old Java class stuff when I still wrote things in Java, because that was what I knew. And I'm like, okay, I will roller.class. Open with, where's an open with? Oh, it's the default. It doesn't know what to do with that. Is it gonna give me an option? No? More options. Notepad. That's not what I want. Class file. That's, isn't there supposed to be a Java thing in there? Oh no, class is the compiled thing. That's why I didn't know what to do with it. Compile Java, because Workspace is gonna have, you know, all these things. Where is rolling? I don't know. I don't know where the... Oh, dice. It's called a different thing. Source. Oh, there's roller. Anyway. For... I don't care. I'll just explode it. By explode, I mean unpack. In os.walk. Is this default? Does it have a default of that? I hope it does. Print star A and wait for input. Nope. Needs the thing. Great. Alright. So here is the directory, and here are the 3 folders in there, and here are 2 files in this top level folder of Java. And now I think it'll go into NidCalc, and here is where we are. So the top level folder Java / NidCalc, and it contains no folders, so that's an empty list, and it has 4 files, which is these things. And then let's go again, and now we are in, since there are no files, I mean, sorry, there are no directories in here, so it'll go back up and then go to the next one. And now we're in rolling. And again, there are no directories, but there are 2 files. And this is a dice rolling program that's probably very large. Well, here is only the class and the batch file that, you know, compiles it. Getting things to run is really annoying. I recommend, if you want compatibility, just use JavaScript. Everyone has the JavaScript interpreter. It's called Chrome or Firefox or Internet Explorer or Edge or Opera. It's just the browser. So. And then it will be Workspace. That was the next folder in here. So we have workspace is where we are in, and there are many folders in workspace. All these things in here, and there are no files just hanging out in this directory. And so if I press enter again, because it's waiting for input after everything, we are in workspace, right? Slash dot metadata. So now we're in workspace metadata. And these are the folders in there, and these are the files in that top level. Press enter again. And now we're in this first thing. Do you see how this works? It's very handy if you want to recursively search through every folder in a folder and look through all of the oh, someone is in chat. I didn't see. When did that happen? 12:48. It was 5 minutes ago. I'm not sure the correct pronunciation of that. Either Jesus JM or Jesus JM. It says Mexico. I'm not in Mexico. I don't know what you're referring to, but hello anyway in chat. We're looking through the os.walk function, which is very handy. So we're in here, and then next we'll be in this folder. So we're in task list index, and this has no directories, but it has these two files. And so next we will be in the contexts folder at this level. And now we're in context, and it is empty. Neat. And since that's the last folder in here, we're going to go up one level back to metadata and go to plugins. And now we're in plugins, and it has all these folders, etc. And I think that's good. I'm gonna do that. So you get the idea. It's handy. Another way to go through folders like this is with the glob module, using glob.glob. But generally I use os.walk. Very handy function. Oh, and note that since I exploded it, right, this actually, as we had seen before, returns a tuple with the directory path, and then a list of the folders that you have here, and then a list of the files that you have. So you can, unpack it for current path names, or current path directories files in os.walk, whatever. And then you can mess with those. What else have we got? Linux extended attributes. Next song. Process management. These functions may be used to create and manage processes. I don't think I'm doing that. Besides, it's all Unix. Next song. Oh, here's a couple Windows things. P no wait and P no wait O or 0? Probably O. Possible values for the mode parameter to the spawn family of functions. I don't care. Nope, nope, nope. os.wait, no. No, 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 no. No. And there's a wait 3 and a wait 4. Is there a wait 2? I have no idea. There's a p wait. Oh, here we are. I almost missed some cool things. os.start file starts a file with its associated application. If you have a default handler for, say, MP3 files, like if you have an MP3 file and you double click it and it opens in like Windows Media Player or something, os.start file with and you pass it the name of the file, will open it. When operation, there's an optional argument called operation. When it's not specified or when it's open, the string open, this acts like double-clicking the file in Windows Explorer, or giving the file name as an argument to the start command from the interactive command shell. In Windows, the command line terminal, you can do start as a command, and then you can pass it the name of something that you want to start. When another operation is given, it must be a command verb that specifies what should be done with the file. Common verbs documented by Microsoft are print and edit, to be used on files, as well as explore and find, to be used on directories. Start file returns as soon as the associated application is launched. There is no option to wait for the application to close and no way to retrieve the application's exit status. What does this mean? When you have somewhere in your program os.start file with a thing, let's say you started a movie or whatever, it will, open Windows Media Player, and then it will immediately keep on going. It's not going to wait for you to close the media player. So that's something to keep in mind. os.system. Execute the command, which is a string, in a subshell. os.system echo hi. In the Windows command line terminal, echo is the command to print something, basically, and I told it to echo hi. So it echoed hi over here and returned 0 from os.system, and here we are again. I'm going to show you some black magic. Print. What? We're in Python. Again, I heard you like Python, so I opened Python while in Python. Can we work with OS? No, because I didn't import it. This is a new one. If I exit, I will be back at the previous one, where OS is right here. Yay! So this is which shell is it going to use? On Windows, it depends on environment variables, specifically comspec. Usually the cmd.exe, which is the basic one. This is PowerShell. This is a different one, which returns the exit status. Blah blah blah. Okay. The subprocess module provides more powerful facilities for spawning new processes and retrieving their results. I have never used subprocess before. Using that module is preferable to using this function. See the Replacing Older Functions with the Subprocess module section in the subprocess documentation for some helpful recipes. That's basically os.system is getting old, and they're giving you a little pamphlet of my favorite function call is getting old, and how do I cope with this? And then you open the little pamphlet and it says, don't fret, there's a subprocess. I've never used subprocess. It's different and slightly harder to use, I think. Subprocess.run, and then you need a list of arguments. Yeah, os.system is a lot easier because it's just say os.system, right? And then you pass it whatever string you would want to run at the command line. os.wait, os.wait ID, .wait PID, wait 3, wait 4, os.w no hang Unix, Unix. Miscellaneous system information. Unix, blah blah blah. Blah. A string of this many random bytes suitable for cryptographic use. Remember the random function that we were going over before? I believe we did that, didn't we? I think I do. Yeah, I remember having fun with saying this is a random stream, but it's actually very specific of random, right? Anyway, the random module is not for cryptographic use. This is os.urandom. So returns random bytes from an OS-specific randomness source. The return data should be unpredictable enough for cryptographic applications, though its exact quality depends on the OS implementation. Linux uses getrandom if it's available and the urandom entropy pool is initialized. On Windows, it will use crypt_gen_random. If a randomness source is not found, not implemented error will be raised. For an easy-to-use interface to the random number generator provided by your platform, please see random.systemrandom. Some new stuff in 3.5 and 3.5.2. Okay, so let's go over some of the major useful things that we had. Get CWD to see what directory you're currently using. os.changedir to change your current directory. Get login, maybe, I don't know. If you want to, if you have a program that wants to guess at the user's name, hi, whatever. Not really a great idea necessarily. Listdir to get just a list of all the objects in this directory. os.walk to go through a directory and tidily manage the name of where you currently are, and a list of all the directories and a list of all the files. And os.system. Wasn't there something else? Could have sworn there was. Oh, start file, yeah. Start file and system. System's pretty handy. If you have, there's something that I just need to go into the shell and do the what's it. os.system. Very straightforward. So I think those are the big ones. Checking the directory where you are. Sending strings to your system's default shell. And os.walk. And, you know, rename files and folders, etc. There's another module for that, and that module is shutil. It's mentioned somewhere here. For high-level file and directory handling, see the shutil module. So that's a different thing for copying and renaming and temporary files. etc. But anyway, that's the OS module in fewer parts than I expected. Only needed one, because a lot of it was extremely skippable, and I did. Hope you enjoyed that. Tomorrow will be a game, maybe League of Legends or Euro Truck Simulator 2. Can I have a convoy? What the? You know? I don't know why the air horn button doesn't do anything. There's the horn and the air horn, nothing happens, and light horn, which is the high beams, but just temporary. So yeah. Get CWD is handy. os.walk, os.system. I think I would put an os.lister. I think I would put that the walk, system, and lister kind of at the top of the usefulness list. But anyway, that's the stream for today. Thank you for joining me in chat, and thanks for watching. More Python stuff later, more games later. That's how it works, you know the drill. So thanks again, and I will see you next time. Have a good one.